This is the video for Unit 4, Lesson 4, Graphing Rational Functions. So the goal we're going to see today is graphing rational functions using asymptotes and intercepts, which we talked about in the first 3 lessons. So our goal is going to be for graphing are just going to be identifying those different components that we've seen. So that includes we want to make sure we're able to identify our domain. With that, we want to make sure that we then have our expressions factored, simplify if needed. So we're later going to talk about how to identify if we've created a whole. We're then going to look at finding our asymptotes, our intercepts, and then using that to go ahead and graph. So our first example we're going to look at, we're going to approach all of these the same way, and we're going to identify our kind of 5 characteristics. So our domain, our horizontal and vertical asymptotes, our x and y intercepts, and then go ahead and graph. So our first thing we're always going to look for to see if we can factor. So the top part is for this function f of x equals 6 over x plus 3. The top part we can't factor. And the bottom part, we also can't factor. So that's as simplified as we can make it. For the domain, remember you set your denominator equal to 0. So when I do x plus 3 equal to 0, my domain is going to be x cannot be 3, which I then see that nothing else really I can do with that x minus 3. That also means I have a vertical asymptote at negative 3. We're then going to look to see for a horizontal asymptote. We have here, I have a 6 on the top, an x on the bottom, so I have a degree 1 on the bottom. The larger exponent's on the bottom, so my horizontal asymptote is y equals 0. So as x goes to infinity or negative infinity, f of x is going to go to 0. So it's going to get really small. And vice versa for positive infinity. For the x-intercepts, remember that's where you set the numerator equal to 0. So I have here 6 equals 0, which wouldn't make any sense. So there's no x-intercept. And then for the y-intercept, I evaluate f of 0, 6 over 0 plus 3, 2. So I have a y-intercept of 0, 2. So now we have all of these components we're going to use now to graph. So when we go ahead and do our graph, make it nice and big, the first thing we're going to do is sketch our asymptotes. So I have one at y equals 0. So I'm going to go ahead and sketch a vertical line at y equals 0. Kind of highlight that so that's easier to see. I'm going to have a vertical line at negative 3. So I'm going to go ahead and sketch negative 3. All right, and so what we just did is we broke up our graph into 4 different sections. So 2 of these 4 sections is where our rational function is going to be living. So we're first going to plot the one of our intercepts. So I see I have 0, negative 2 as an intercept. I actually don't have an x-intercept. So I'm going to go ahead and plot 0, 2, which is I don't go left or right, but I just go up 2. And then we're also going to have, we know that the same point is going to be reflected on the other side. And so what we're going to now do is go ahead and do our best to draw a sketch that would go through that point. And then we're going to do the same on the other piece, right? So it's almost like we have like these little vertical, not vertical angles, but we have these vertical sections, and that's where the graph is going to end up living. And then that would be it. So that would be our rational function. For the next example, the U-try, we're going to have U-try out. The next example is almost the same concept. So we're going to go ahead and identify our different components here. So I'm first going to look to see if I can factor the top and the bottom. There's nothing we can factor there, so we're going to move on to like our next piece. The domain, I'm setting that bottom part equal to 0. So my domain is x cannot be 4. We're going to see that, there's nothing else I can simplify, and that'll make more sense in the next video of why we don't need to simplify anything else. That means our vertical asymptote is at x equals 4. And our horizontal asymptote, again, if I was to write this out, I have 2x. In this first one, I have a 1x. And then if I was to go ahead and simplify these, you can see this cancels out to be -2. So my y equals -2, it will be my horizontal asymptote, right? So again, I'm just taking those leading coefficients from the numerator and the denominator and seeing what that behavior is going to end up being. So since they're the same, they'll cancel. They're the same degree, and I would get -2. For the x-intercept, I'm going to set the top part equal to 0. So again, that's like if I set this whole function equal to 0 and solved. So we have 2x plus 7 equals 0. And then if I go ahead and solve that out, I would get here x is -7/2. So -7/2, 2. And then the y-intercept, I'm going to evaluate what f of 0 is. So if I go ahead and put a 0 in, we actually will get this to be here. This would be positive 7/4, right? Because this is a 0, and then we still have that negative out front. So 0, 7/4. We're now going to go ahead and graph it. So our horizontal asymptote is at -2. So I'm going to go ahead and draw like a little dashed line at -2. We're going to have a vertical line at +4. And now I'm going to go ahead and plot my intercepts. So I have one at -7/2, which is roughly -3.50. So that's going to be to the left. We're also going to have one at y-intercept at 7/4. So that's like 1.75 about. So that's right a little bit above the origin. And so that means one part of my graph is basically in this upper left piece of the graph. And so I know that my other piece is going to be in that diagonal area, right? So they're going to be across from each other still. Right? So the U-tries you can try out, so same concept. If you have any questions, feel free to ask them in class, sign up for T-Bolt time, or go to the center.